Welcome to Physical Science, Module 12. We'll be beginning with another intro to forces in creation. This will be part 2 about electromagnetism. We'll be talking about the electromagnetic force, the background on James Clerk Maxwell, and Michael Faraday. So James Clerk Maxwell was considered, or is considered, to be the founder of modern physics. He was born in Scotland in 1831. He educated himself until he was accepted at university at 14 years old after writing a paper, a scientific paper, and presenting it. He met Michael Faraday, another scientist, after graduating from Cambridge University. His theories laid a foundation for electromagnetic study. He's known for creating the mathematical foundation for the kinetic theory of gases, how gases move. We went through this in Module 3. That theory was expanded to the kinetic theory of matter. He was the first to explain how we see color, and he made the first color photograph in 1861 at the age of 30. He advanced the field of thermodynamics. Faraday, who he met and did many of his mathematical equations, was the inventor of the electrical generator and transformer. Michael Faraday is also known for electrolysis, which is using electricity to combine chemicals that wouldn't naturally combine. And without him, we probably wouldn't have many items like vehicles that have electrical generators, or be able to conduct electricity like we do with the transformers on your light poles. So what is electromagnetic force? The basis behind electromagnetic force is that all electrical charges attract or repel one another. Like charges repel and opposite charges attract. The force between charged objects is directly proportional in the amount of the electrical charge on each object. And the force between charged objects is inversely proportional to the square of the distance between the two objects. These explanations should sound familiar. If we replace the word electrical charge with the word mass, you have the statements that were used in Newton's universal law of gravitation. Two major differences between gravitational and electromagnetic force. The force between electrical charges can be repulsive. Gravitational force, as you should remember, is always attractive. The force between electrical charges is significantly stronger than gravitational force. Remember also that the gravitational force is the weakest force. So let's talk about electromagnetic force in relation to gravitons. Physicists today believe that because the force between electrical charges acts like the gravitational force, that there must be an exchange of particles in gravitational force just like there is in electromagnetic force. And that leads them and bolsters their acceptance of the theory about gravitons. However, many scientists, and in particular Christian scientists, believe that Einstein's theory of relativity is correct, and there's no need to believe in graviton theory. They believe that God could have designed space and time to curve just right in the presence of mass so that electromagnetic and gravitational force would behave similarly. So, from our last unit, we talked about the discussions about both of these theories and how they continue on. You have two on your own problems in this unit. Number 12.1 says, For the diagrams below, which they show you positive particles here, they want you to use a blue arrow to point out the direction of force exerted on the red ball by the blue ball, and these balls represent particles. In addition, draw a red arrow to indicate the direction of force exerted on the blue ball by the red ball. So in A, what we need to do is show the first part of the force that we learned about, that like charges repel. So in that case, if like charges repel, the blue ball would repel the red ball, and they would travel in opposite directions. In B, we have the red and blue ball, but they attract each other. So we would draw arrows showing that they're pulling each other towards themselves. On your own problem 12.2. This is very similar to 11.1 and the problems in the on your own problems for 11.1. It says two charged particles are placed 16 centimeters from each other and the resulting force is measured. The charge on object number 1, so we'll call this number 1, is then halved, so cut in two, and the charge on object 2 is divided by 4. The distance between the objects is also reduced to 4 centimeters. How does the new force compare to the old force? So, electromagnetic force, we've learned in this unit, is directly proportional to the charge of each subject. So when one object's charge is halved, the electromagnetic force is halved. And when the other object is divided by 4, then its electromagnetic force is divided by 4. So if you divide it by 2, its force is halved. That's basically what they're saying. So the force was divided by 2. It was then again divided by 4. And we're not talking about separate objects here. We're talking about the force on those objects. So we divided the force by 2 and then again by 4. That's the same as saying divided by 8. So if you divide by 8 and then multiply by the distance of 16 centimeters, you've really multiplied by 2. So the new force will be twice as strong as the old force. So out of all of this, what you get is whatever you do to that old force, the new force will be twice as strong as the old force. So if you halve the old force, the new force will be twice as strong as that. We'll work a little more with those type of problems, and we'll talk again in 12B in the next video.